Good morning, guys. Welcome back for another question from Matrices, and I'm already really sorry in advance because my voice may stutter today. It's really been cold here. So, without further ado, let's dive into the question. Let's see what does the question say. We have three matrices A, B, and C, and we have to operate some operations on them. So, let's see what's the first one. We have to find A plus B. So, I hope you already know that to implement such type of operations on matrices, like we have to compare two matrices equal or not, or we have to see whether the elements of the two matrices are corresponding to each other and they are equal to or not, or we have to add or subtract the matrix from each other. Then what we do, we only apply the property on the corresponding elements. I mean, if we have to add A plus B, then we can only add A ij plus bij, and the value of I comma j should be same for both. If I and j are not same for both, then we cannot add the two matrices. If I say I and j, then I is equal to 1, j is equal to 2 for both. It is not possible that first matrix has I is equal to 1 and j is equal to 2, and the second one has j is equal to 3. Then we cannot add the elements. So we have to keep this thing in mind. So let's do. We have our first matrix, that is A. Elements are 2, 4, 3, 2, and B is 1, 3, minus 2, 5. So we have to add both the matrices. So we add the corresponding elements of the elements. I mean, we add 2 and 1, we add 2 and 3, we add 3 and minus 2, and we add 2 and 5. So let's move to the next step. Yeah, they have done the same thing. So what they have done, they have added the corresponding elements, as you can very well see over here. They have added both the corresponding elements, 2 plus 1, 4 plus 3, 3 plus minus 2, and 2 plus 5. So let us move to the next step. So we have our final matrix as A plus B is equal to 3, 7, 1, 7. This is our answer. Now moving to the next part, we have three matrices over here, A, B, and C, and we have their corresponding elements. This is A, this is B, and this is C. And the operation we have to perform is that we have to subtract B from A. We have to perform A minus B. So again, remember the same property that we have to subtract on the corresponding elements, and the order of both the matrices should be equal. I mean, if the order of first matrix is 2 into 2, then the second matrix should also be 2 into 2 matrix. Otherwise, we cannot perform the subtraction operation. So let's perform the subtraction operation. Okay, so we subtract the corresponding elements only. I mean, we subtract 1 from 2, we subtract 3 from 4, we subtract minus 2 from 3, and we subtract 5 from 2. So we must get our answer as 1, 1, 5, and lastly 2 minus 5 is equal to minus 3. Let's see what is our answer. Okay, yeah. So we got the same answer as they have A minus B is equal to 1, 1, 5 minus 3. So this part is done, I hope. Now moving to the next part, we again have three matrices A, B, and C, and this time we have to perform 3A minus C. That means first we have to multiply a constant with a matrix, that is A, and then subtract C from the resultant matrix, from this matrix. So we have our A matrix here, and we have to multiply this matrix with 3. So let's see. Okay, so they have 3A here. This is A matrix, this is C matrix. So multiplying 3 with A matrix, we get 3 into 2 is equal to 6, 3 into 4 is equal to 12, 3 into 3 is equal to 9, and 2 into 3 is equal to 6. So we have 3A as 6, 12, 9, 6, and we have C as it is. Now we just subtract the corresponding elements of both the matrices. So let's see what they have done. Yeah, they have subtracted the corresponding elements only. And our final answer is 8762. This is our final answer. Now moving to the next part, we have our two matrices as A. This one is the A matrix and this one is the B matrix. And at the last we have to perform A into B. Now this is very important. You cannot directly multiply the corresponding elements in this case. We have to think of some another idea, and the idea we have to remember is that the most important property in matrix multiplication is that if we are given two matrices A and B and the order of this matrix is R1 cross C1 and the order of this matrix is R2 cross C2, then to perform the multiplication operation we have to make sure that the number of columns in the first matrix should be is equal to the number of rows in the second matrix. If this condition satisfies, then we can apply the multiplication operation. Otherwise we cannot perform this operation. So let's see. This matrix has order 2 into 2. This matrix also has order 2 into 2. And we see that the number of columns in the first matrix is equal to the number of rows in the second matrix. So let's do. Okay. So how we perform the multiplication operation? What we do? We go in the first matrix column wise, and in the second matrix we go row wise. So for the first element of AB, that is this one, for the first element of this AB, we multiply 2 into 1 and we multiply 4 into -2. I hope you all are getting it. Let's see for the another element. For this element, what we do? We multiply 2 into 3 and 4 into 5. For the third element, what we do? We multiply 3 with 1. The first, let me erase it, otherwise it will get very problematic. Yeah, let me erase this one. Okay. I hope you all got the beginning parts. Now I am moving to the third element. Now we have to find this element. Then what we do? As I told you, we move horizontally in the first matrix and we move vertically in the second matrix. So to find the third element, we multiply 3 with 1 and 2 with -2. And for the fourth element, we multiply 3 with 3 and 2 with 5. And we get our answer something as this matrix. This is AB. So now let us simplify the expressions. We get our final answer as -6, 26, -1, 19. These are the 4 elements in AB. I hope you all got it. Thank you. Okay, now moving to the next part. We have the fifth part, that is we have two matrices. A is this one and B is this one. Now we find BA. Now the thing to remember in this question is that they are not asking us to find AB. They are saying we have to find BA. And in matrix multiplication, AB is not equal to BA. For example, in normal algebra, we know that 2 into 4 is equal to 4 into 2 is equal to 8. But this thing does not happen in matrix multiplication. AB is not equal to BA. But we have to remember one property, that is I already told you that the order of the the number of columns in the first matrix, should be is equal to the number of rows in the second matrix. So this time our first matrix is this one and our second matrix is this one, and the number of columns in this matrix are 2, and the number of rows in the second matrix are 2. So now we can apply the multiplication operation on the matrices. So let's find BA. So as I earlier told you, in matrix multiplication we move horizontally in the first matrix and vertically in the second matrix. Now to find the first element, that is this one, we multiply 1 with 2 and 3 with 3. I hope you are getting it. For the second element, this one, we multiply 1 with 4 and 3 with 2. 1 with 4 and 3 with 2. Now let me erase this part so that I can show you how to find the third term and the fourth term. Okay, so we move horizontally in the first matrix, we move vertically in the second matrix. So this is our third element. So how to find this one? We multiply this with 2 and 5 with 3. And similarly, for the fourth element, we have to multiply -2 with 4 and 5 with 2. And we get our final answer as 11, 10, 11, 2. Our BA is equal to this. I hope you all got it. Thank you.